So let's find all values of theta such that cos of theta is equal to -1. So let's take the cosine function, or the graph. So I could do this using the unit circle, but I just want to get practice with the graphs. So what am I looking for? Well, I'm looking for all values where it's equal to -1. So -1 basically is at the bottom here. So what do I have? Well, I'm trying to look at all positions where I'm touching the bottom here. So this should be reasonable. So I know the picture's not perfect, but so this should be raised up a little bit, I think. Oh my goodness. Yeah, it's a bit better. So what do we need to do? We need to work out all the possible bottoms, if you want, of this. So this is a graphical way to do it, not using the a graphical way to do it, not using the unit circle. I'm just going to use the graph. So first off, let's work out some important positions. This position is clearly important. Where is that? That's equal to pi. Now, where else does it happen? It happens elsewhere a certain distance away. It's always the same distance, okay? And what length is this? Well, this is the length that repeats itself in these blocks. This is 2 pi. So visually looking at this, I can see where I'm going to be 0. It's only going to, or -1, it's only going to happen on the base here. So it's going to happen basically at pi, clearly, and then it's going to happen at integer multiples of 2 pi. So cos of theta is going to be equal to -1 if and only if theta is equal to, let's say, pi plus 2 pi times k, where k is an integer. So that represents the number of blocks you're going, either in the positive direction if k is positive, or the negative direction if k is negative. So again, this could have been done with the unit circle by looking at the x-coordinate being -1 on the unit circle. That would give you pi, and then you'd have to have full rotations, which would be these multiples of 2 pi. But again, good practice getting to understand the graph.